Hello students, I want to welcome us to another virtual learning, virtual classes. Previously we handled Surds, and on the Surds we looked at simplification of Surds. And by way of revision, I remember I told us that there are two ways of simplifying Surds. You can actually simplify it to become a square root of a single integer, or you simplify it to its lowest term. So both ways are simplification, but we normally use the one of the lowest term. Okay, so that was what we handled in the previous classes on Surds. Today we'll still continue with Surds. We'll still continue with the same topic, Surds, but today we'll be looking at addition. The four basic operations in mathematics. We're looking at addition, subtraction, multiplication, and division, if time permits us. So we'll start with addition and subtraction of Surds. They go hand in glove. Addition and subtraction of Surds. So that is what we want to look at today, how to add, subtract, sort. Now, we know very well that whenever in algebra, that is a mathematics that involves alphabets. Whenever we want to add or subtract, we make use of like terms. For example, you know that x plus y is equal to x plus y. Why? Because they are not like terms. So you can't add them together because they're not like terms. You can't mix water and oil together. So if you have x minus y, it will also be equal to x minus y. We've already established this fact in our JS classes. Okay, we also know that for like terms, we say x plus x is equal to 2x. We've added them together because they are like terms. Y plus y is equal to 2y. Something applies to that. So in algebra, we add and subtract like terms. So if they are not like terms, we don't do anything. The question is the same as the answer. The same thing applies to Surds. For us to add or subtract Surds, we do two things. One, we simplify to the lowest form. And then secondly, we collect like terms. So we're going to be looking at some questions now. We're going to be adding and subtracting them. First thing we do is if they're not like terms, okay, if they're like terms, we add. If they're not like terms, we don't add. But see whether you can simplify it to the lowest form. After simplification, you can now check whether they are like terms or they're not like terms. If they are like terms, you can add or subtract. If they are not, the question is the same as the answer. Okay, so now let's look at, so what I'm trying to say is that, for example, if you have root p, we have root p plus root p. You can see they are like terms, the same p in the root. So to give us, how many p's do we have here? 2 root p's. So 2 of root p. If I have 2 root y plus 3 root y, you can see they are the same, they are like terms y. So you add the numbers outside, 2 plus 3 gives us 5. Give us 5 root y. This is for the addition. This is like terms. Okay, you can see that. Okay, another illustration. If you have under subtraction, you can say 4 root m minus 1 minus root m. And then on unseen 1 here, so you can say 1 root m or root m. That's the same thing. This will give us 3 root m. So they are like terms. That's how we can add or subtract them. But if they're not like terms, like say I have let's say 5 root t, okay, plus 2 root x. Okay, let's say x. You cannot add or subtract them because they are not like terms. So it will be equal to the same thing. The question is the answer. It will give us 5 root t plus the same to root x. So you can only add or subtract numbers, sorts of the same, that have the same, they are like terms. You can only add or subtract them. The numbers inside the root must be the same. That's what we're trying to say. After simplified, when it's been simplified, the numbers inside the root must be the same before you can add or subtract. Now let's look at some examples under this addition and subtraction of sorts. So simplify example. Simplify the following. Number 1, we have 4 root 2. We have plus 6 root 2. We have other ones. We have 3 root 5 plus 7 root 5. We have 3 root 8, number 3. We have plus root 50. Number 4. We have 2 root 27 minus root 75 minus 5 root 12. Number 5, we have root 45 plus 3 root 20 minus 8 root 5. So these are the questions we're going to be looking at now. With this, you can see addition is here, addition, subtraction, addition and subtraction. So they go together. So we're going to be simplifying to the lowest form. You can see this number 1. You can see root 2, root 2. So it's in the lowest form. And they are like terms. So you can add them. Root 5. They are the same in like term and the lowest form. You can add them. This one, that will be need for us to simplify. This 8, the 50, the 27, the 75, the 12, the 45, the 20. Okay. Then before we can now know whether they are like terms or not. Okay. So now trying to solve, let's start with the number 1 question. Now you've got the question, so now let's look at it. I know you're done with all these things. Okay, let me give us some few time to look at it again. Okay, so I can now clean it. Let's look at this number 1. I want to add these two sorts. So you can say solution. So I want to add 4 root 2 plus 6 root 2. Okay, this will give us, you can see they are in like terms. We have 2 here. We have the same 2 here. So they are like terms. So we add, so since they are like terms, we just add the numbers outside the root. So it will be 4 plus 6 root 2. Which will give us 10 root 2. So just add the numbers outside the root if they are the same. Root 2. Okay, now quickly let's go to number 2. Number 2 question. Number 2 question says 3 root 5 minus 7 root 5. 3 root 5 minus 7 root 5. Okay, plus. So this will give us, you can see they have the same number inside the root 5. So they are like terms, and in the simplest form. Okay? So since they are in the simplest form and they are like terms, what do? We add. So add the numbers outside. This will give us 3 plus 7 bracket root 5. 3 plus 7 will give us 10 root 5. So we simplify. These ones are already simplified. That's why we didn't simplify. So we simplify. We now check for like terms. Let's quickly look at number 3. I know you have written this one. Okay. So you should be in number 2 by now. Okay, now let's look at number 3. Number 3 says 3 root 8 plus root 50. 3 root 8 plus root 50. Okay, you can see for yourself that this 8 and this 5, they are not in the lowest term. There's actually a perfect square that can divide 8. There's a perfect square that can divide 50. Okay, so we have to simplify first before we add. So now let's simplify. So look at this 8. 8 is the same as, what's the biggest perfect square that can divide it? You know that 4 can divide 8, and when 4 divides 8, to give us what? 2. So 8 is 4 times 2. Plus root 50. What's the biggest perfect square that can divide 50? You can see that 25 can divide it. 25 divide 50 will give us 2. So 50 is 25 times 2. Now, still simplifying, this will give us 3. We separate them. Separate the roots. This is times root 4. Okay, I'm separating this times root 2. That's for this. This is this. This is this. Okay, plus this is root 25 times 2. To avoid confusion, it's advisable you can put your bracket sign so that you don't get confused. Times root 2. Times root 2, not just 2. So 25 is the root, 2 is in root. Okay, so this will give us 3 times root 4. Square root of 4 is 2. Square root of 3 will give us a decimal. We don't want that. Plus square root of 25 is 5. Square root of 2 is still the same. We don't want the decimal answer. So this will give us 3 times 2, 6 root 2 plus, sorry, this is times, not plus. So plus 5 times that will give us 5 root 2. Finally, what do we have? They are like terms now. So you can go ahead and add. You can go ahead and add. They are like terms. So add 6 and 5. So this will give us, continuing from this side, this will give us 6 plus 5 root 2. 6 plus 5, what will it give us? Give us 11 root 2. So what you can see for yourself that what we did here was that we had to add this, and we discovered they are not like terms per se, and they are not in the simplest form. So I have to simplify it to the lowest form. So this is my way of simplifying it. From here, I simplified it. I got to this point. And when I'm done simplifying, I discovered they are now like terms. This is 6 root 2 plus 5 root 2. The same root 2 root 2. So it's more like 6x plus 5x. So we went ahead to add the 6 and the 5 to give us 11 root 2. So quickly, let's look at number 4 question. I'll leave you with number 5 to go and do. So let me just do number 4. Hope I don't copy in this one. Let me just give you some time to copy this one. So for number 4 we have 2 root 27 plus, minus root 75 minus 5 root 2. Let me clean up everything. Avoid confusion. Okay, now. So you can see this one, they are not like terms per se. If you look at it. This one needs simplifying. This one needs simplifying. This one is already simplified. Because this one, there is no perfect square that can divide it. Except 1. Okay, now let's go ahead. This is 2 root 27 is 9 times 3. Why am I taking 9? Because 9 is a perfect square. Minus 75. What's the perfect square that can divide 75? Know that 25 can. 25 divided 75 give us 3. So 75 is 25 times 3 minus 5 root 2. This will give us 2 times square root of 9. Square root of 9 is 3. There's no square root for 3, so I'll leave it like this. Minus square root of 25 is 5 times square square root of 3 minus 5 root 2. Going ahead, we have 2 times 3, 6 root 3 minus 5 root 3 minus 5 root 2. You can discover that not all of them are like terms, but we have some that are like terms. We have this and this. They are all root 3, root 3. This one is root 2. So what do? We work with those that are like terms. So this will give us 6 minus 5, which is 1. You can say it's 1 root 3, or you can just say it's root 3. Do you understand? So every number has 1 by the side. So we can say this is 1 root 3, or we can just say it's root 3. That's how you want to say it. So, but let's leave it at root 3. So 6 root 3 minus 5 root 3 is 1 root 3, or just root 3. Okay, minus 5 root 2. So this is the answer. We cannot add this, we cannot subtract this and this, because they are not like terms. This is root 3. This one is root 2. So we cannot do anything to it. This is our final answer for this addition and subtraction. So number 5, I'd like us to go and try number 5. Check the way I did my own. Those that are not like terms, see whether you can simplify them. If you are done simplifying, you cannot collect like terms in your addition or your subtraction. So this is how to add or subtract sorts. So you simplify. After the simplification, then you can now collect like terms. Okay, so with this, I think we've mastered the art of adding and subtracting sort. So we want to look at multiplication of sorts. Let me give you some time to copy this one. I want to look at, still under sort, we want to check multiplication of sorts. So that we can do the 4 basic mathematical operations in sorts. We can add, we can subtract, we can multiply, we can divide. So we want to look at multiplication of sorts. Okay, now in multiplying sorts, it's very important we know that that root p times root q is equal to root p times q. You put them inside one root. Root p times root q. This is what we always see, even in indices. You know, sort is related to indices. So, like if I have, let's say I have p square times q square. Okay, the powers are the same. So it can be pq all raised to power 2. Because the powers are the same. Okay, so this one we're checking the roots are the same. Do you understand? pq means p times q. So it's still pq. So what we're doing here is root p times root q. They are in the same roots. So what do? You pick one root for all of them. All of them pick one root, and then p times q. This will give us roots pq. So this is what we need to know in multiplication. With this, we can multiply sorts. With just this. Okay? So you can from this go backwards to this, or from here go like this. So it's both ways. You can go like this, or you can move back this way to multiply sorts. Now, let's look at some examples on multiplying sorts. Let's look at some examples on multiplying sorts. So we're going to multiply with the following examples. We have root 27 times root 50. We have root 12 times 3 root 60 times root 45. We have, let me just give us this one. We have root 3 times root 6. We have 2 root 5 all square. And finally, we have root 2 times 3 times root 5 times root 12 times root 45 times root 50. Now, let's look at these examples. We have 5 examples here. This one, this one, and this. So we're going to start. Please remember the first thing I said, to just put them into one root and multiply. Or you can also simplify and multiply. It depends on the way you prefer. Okay? So for this number 1, I will try with the 2 methods. I can simplify and multiply this one. I can go ahead and multiply by using the first principle I gave us. Okay, now let's look at this number 1. This number 1 have root 27 times root 50. Let me take it up here. So solution. Root 27 times root 50. So how do we multiply this one? So I told us we can go ahead to put them into one root and multiply. We can put them into one root and then multiply. Or we can simplify and multiply. So it depends. The numbers are huge. So putting them into one root might be big for you. You might need the aid of calculator, which is not supposed to be like that. You're not supposed to use calculator in Surds. So what we do to make it easier for us, you can put them in one root, or you can do this one. You can simplify each of them. Simplify this 27. 27 is 9 times 3. Look for perfect squares. Remember I said it before. So 9 is a perfect square. 9 times 3 is 27. 50 is 25 times 2. You can say I'm not using 10 times 5, which is also 50. I'm using the one that has to do with perfect squares. So perfect squares, so we can easily get their square root, because square roots of perfect squares are whole numbers. Other ones will give us decimal. Okay, now, so let's work on this. So we separate them. This is root 9 times 3 times root 25 times root 2. Okay? Now, we can do it this way. Root 9 will give us 3 times root 3. Root 25, the square root of 25 will give us 5 times root 2. If we were to multiply out, 3 times 5 will give us 15. Then roots 3. Okay, let me just write that so you can see what I just did. This is 3 times 5. I'm just taking whole numbers to whole numbers, root to root. Times root 3 times root 2. This will give us 3 times 5 is 15. Root. Put this one and this one into one root. 3 times 2 is 6. So the answer is 15 root 6. So that's the answer to this multiplication. You can see it's better you simplify and multiply. You can also put them into one root and multiply, but it might give you something big. Then you may not know the perfect square. I'll work on it. Okay? Like normally you can say that this is the same as root of 27 times 50. Now, and it's going to give you something very big. And you might end up not knowing how to simplify it. So you can work it this way if the numbers are big. If they are small, you can put them into one root. So quickly, let's look at number 2. Let me give you time to finish copying this one. Number 2 says that root 12 plus times 3 root 60 times root 45. These are number 2. Look at these numbers, discover that they are big. This number is big. This multiplying is going to give you something very big. So it's always advisable you simplify. So you can simplify for big numbers, for small numbers. Though all of them works. But for big number, it's advisable you simplify. So now let's simplify. Let's simplify. Here, as a perfect square, I can divide this. 12 is 4 times 3. Okay? Times. This is 3. I can say 3 times or 3 roots. 3 is multiplying this root 60. Okay? 3 times. What's the perfect square? I can divide 60 here. Is it 12? Is it 4? Which one can divide this one? 12 is not a perfect square. 4 can divide this to give us 15. Can we say that 60 is root 4 times 15? I think that one will be the biggest perfect square. Out of 9, can 9 go? If 9 is to divide 60, will it go? Yes. I think 9 can divide 60. 9 into 60. Okay, 9 cannot divide 60. Cannot go. It can divide 63. So let's work with 4. So 60 is 4 times 15 times 4 root 45. Which perfect square can divide it? Can 4 go? No. Can 9 go? Can 9 go? Okay. 9 can go. What about that perfect square? 16? No. So let's try 9. So 9 divided 45 will give us 5. 45 is 9 times 5. Okay, so we go ahead. So this will give us, let me clean up this one. So this will give us 2 root of 4. Square root of 4 is 2. This is 2 root 3. Okay. And this is 3. And this is 2 root 15. Times, what do we have here? We have root of 9 is 3. Root of 5. So go ahead. You have 2 into this. So collect like terms. Okay, let's multiply all the whole numbers. 2 times 3. 2 times 3 times 3. We have 2 times 3 times 3. Then the root times root 3 times root 15 times root 5. This will give us 2 times 3, 6. 6 times 3 is what? Give us 18. So this is 18 root. Okay, now, if you look at this very well, I don't just want to go ahead and multiply. But you can see that this is 3 times 15 times 5. So you can just rearrange it to be 3 root of 3 times 5 times 15. If you look at this very well, you discover that, look at this, you discover that 3 times 5 is 15. And this is another 15. So which means that inside here, what we have here is 18 root 3 times 5 is 15 times another 15. So when you have square roots of two numbers, a number multiplying itself, the answer is one of the numbers. For example, if you have now look at this. If I have root of a times a, this root is for both of them. The answer is just a. There's no need trying to, because this is root of a square, you understand? So now root of 15 times 15, the answer is just 15. So what I'm going to have is that I'm going to have from here that 18, this will be 18 times, root of 15 times 15 is just 15. And when we have that 18 times 15, 18 times 15, what will it give us? Let's multiply it so we can see how we're going to get it. This will give us 18 times 15. 5 times 8 is 40. Right? 0 carry 4. 5 times this is 5 plus that. That is 90. 1 times 8, 8. 1 times 1, 1. So you add it together to bring down 0. 9 plus 8, 17. Right? 7 carry 1. Put it here. This will give us 270. So which means that 18 times 15 is equal to 270. So you can see that this question that is in sort form ended up giving us a whole number as the answer. Some questions in sort, the answers can actually be whole numbers, especially when your answers are in perfect squares. Then you can see this 15 times 15. Ended up giving us 15, and then 15 times 18 gave us 270. Okay, you can see it for yourself how I got them. Now, I'll just lastly do number 3, and then I'll just do number 4. We do number 5 as usual. Number 4 says that 2 root 5 all square. That's our number 4 question. 2 root 5 all square. So if we have 2 root 5 all square, whenever we have power is also related to multiplication. This thing is just by expression that 2 root 5, this is the same as 2 root 5 multiplying itself again times 2 root 5. It's multiplying itself 2 times. So it's multiplying itself, you can see it for yourself because of the square. If it's raised to power 3, it will be 2 root 5 times 2 root 5 times another 2 root 5 in 3 places. So now, we multiply. Collect the whole number with the whole number. This is 2 times 2 times root of 5 times 5. This will give us 4 root 25. Or you can say 4 times root 25, which will give us 4 times 5, which is 20. So you can see that 2 root 5 raised to power 2 means it will multiply itself. This multiplying itself. Collect the whole numbers, 2 times 2, and then root 5 times root 5 is in 1 root. So 2 times 2 is 4. This will give us root 25. Finally, we have 4 times 5, which is 20. So I want you to go ahead and do the number 5, which I know you must have written down. I wrote it down for you. So you can go ahead and do the number 5. So this is how we do multiplication of surds. Okay? You can put them into 1 root, multiply, or you can simplify and also multiply, especially when the numbers are huge numbers. It's expected of you to simplify before you multiply, because if you multiply straight, you might need to use calculator, of which in this particular topic, we don't use calculator. It's expected that you do everything with your head. Okay, now, finally, the last part of this, we look at division of surds. Division of surds. Division of surds. Division of surds. Now, in dividing surds, this one will lead us to probably conjugates and rationalization. What do we call conjugates? Conjugates are when you have something like x minus plus y. The conjugate of this is just x. You change the sign in between them from plus to become minus. This is conjugate of this one, and this is also conjugate of this. We'll make use of this as we go ahead. And also, we'll also look at rationalization. Rationalization means to remove the root or the surd from the denominator. Remove the root from the, for example, if you have 3 root 5, we have to work on this. In rationalization, we'll solve in a way that this root you are seeing will disappear from the denominator and either go up or disappear entirely. So, in this division, we don't allow square root to be in our denominator. Square root doesn't stay in the denominator in our answer. So we work on it to rationalize. Now, the question is, how do we rationalize? How do we rationalize numbers? How do we rationalize in surd? How do we rationalize? By rationalization, we mean you change the number to a whole number. Rational numbers are whole numbers. So, if we want to rationalize, assuming we have root 5, we have to rationalize it. This is an irrational number. Okay? Okay, so in rationalization, we're trying to say, let this root 5 be a whole number. How can it be a whole number? Assuming I just clean up this root now, it's good that if I clean up this square root now, this is normal 5, whole number. Okay, but if I put back the root, it's not our normal 5 now. This is square root of 5, or which we call root 5. So in rationalization, what do? We try as much as possible to remove these roots from the 5. So if we remove the roots from the 5, it's no longer an irrational number. It becomes a rational number. And from rational, that's where we get the word rationalize. Make it rational. Make it a whole number. So now, if I have this and I want to rationalize it, what do I do? Simply what you do is multiply this root 5 with the same root 5. That is how to do it. If I want to rationalize this, this will be root 5, this root 5, times, that's in rationalization, not like it's equal to, it's not equal to it anyway. But if I want to rationalize it, it will be, okay, that root 5 will multiply itself. And by so doing, this will give me, this particular solving will give me root of 5 times 5. Put the root, this is one root, put them in one particular root, then 5 times 5. And then which will give us root of what? 25. And what is the root of 25? 5. So you can see that by doing this, the root disappears and the 5 is the only thing remaining. So this is one of the things we're going to be doing under division. We'll rationalize, we'll also make use of conjugates. So I want to look at some examples under this rationalization. Now, in rationalization, I also want to quickly say that when we rationalize, we don't just multiply. We multiply both the numerator and denominator. You know, division has to do with the numerator. There must be one up, there must be one down. The one down is denominator, the one up is the numerator. Assuming you have 3 root 5 now, and you want to rationalize it, you multiply this particular thing with this surd part, the surd part. You use this root 5 to multiply up, and also use it to multiply down. You multiply it up, and you multiply it down, so that you will not change the question. If you multiply only up, if you just say times root 5, you have changed the question. The question has changed. But when you do it up, you know the Lord's Prayer, which says that as it is done in heaven, so shall it be done on earth. So if you do anything in heaven, you don't do it on earth, it's not balanced. So we multiply the numerator, we also multiply the denominator. This is how we rationalize. So we're going to look at some examples under this rationalization so we can master the art of rationalizing surds. Now, let's look at these examples. Number 1, we have 6 root 2. Number 2, we have 7 root 18. 7 root 18. Number 3, we have 5 root 5. Okay. Number 4, we have root 18 over root 2. Number 5, we have root 5 over root 2. And then we have number 6, root 16 over root 7. So we're going to rationalize or solve this. This is division. Whenever there is over in surd, is division. This is division. You can say over, 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 all over, all over. So it's division. It's more like fraction. In division, most questions we see they are in fractions. Okay? We have the numerator, denominator, numerator, denominator, and all that. So we're going to solve this now by rationalization. Okay. Now, it's good we note that in rationalizing surd, further we know that it's good we note that root q over root p is equal to, this is root p over root q over root p. Is equal to, put them into one root. There's this root and this represented is just one root. Then it just be q over p. It's good we note this because we're going to be making use of these two. So I've said 3 things we're going to be making use of Okay, none of these ones has to do with conjugates, but normally in this we make use of conjugates, rationalization, and then this one comes into play too. Now let's solve the questions. I know you are done copying this one. Okay. Okay, now let's do the number one question. Okay, I'll keep looking at this one. The number one question says 6 over root 2. 6 over root 2. Okay, so how do we solve this? There are many ways we can do this anyway. Okay, but one of the ways you can do this is, if you want, you rationalize. I will just give us two ways to doing this. You can rationalize. The rationalization in the sense that this is 6 over root 2. This 2 has a square root. 6 doesn't have square root. And in rationalization, what do? We make sure the square root in the denominator disappears. I need this square root here to run away. And how can I do it? I'll use this root 2 to multiply up and use it also to multiply down. So it's going to be that this thing is 6 over root 2 times, I'll use this root 2 to multiply the numerator and also use it to multiply the denominator. Okay, this will give us 6 times that is 6 root 2 all over. Root 2 times root 2 is root 4. Or you can say is root of 2 times 2. That's one root for them, then this number times the other number. This will give us 6 root 2 all over root 4. Okay, which will give us 6 over root 2 all over. What's the square root of 4? Is 2. So you can say this is the answer. I'm done with the question. Okay, because roots have finally removed the roots from the denominator. It has gone up. It can either go up or it can even disappear. Just make sure it is not in the denominator anymore. So this root sign is no longer here. It has gone up. You can see it. My final answer is not here. It is here. So this can be the final answer. Okay? Or even in JAMB, you may not see this as the final answer because these two can divide the 6. The 6 can be divided by the 2. Now, this will give us 2 cancel itself, give us 1. 2 into 6, give us 3. So the final answer is 3 root 2. So this can be our final answer. I will tell us 2 ways. This is one of the ways to solve that. Okay? There's another way of still solving that question. There's another way of doing it. But for now, let's just stick to this because of our time. I will not start showing us that. But you can go and find out other ways of doing this. But this is one of the ways to rationalize that. Then for the number 2 question, which will have 7 over root 18. 7 over root 18. That's the question that we have. So how do we? You can see there is root here and there is no root here. And again, it's good you note too that root 18, this 18 is not in the simplest form. It's good you note that. Because there is a perfect square that can divide 18. There is a number that can divide 18. Perfect square actually. That can divide 18. What is that perfect square? 9. 9 can divide 18. So it's good we simplify this 18 before we start rationalizing. Okay? Okay, now, this will give us 7 over, let's rationalize this in a little bit. 18 will be 9 times 2. Okay? Now, this will give us 7 over, square root of 9 is 3. Square root of 2 will give us a decimal number, but we don't need it. So let's still put the 2 back in the root. So this square root of 9 gave us 3. Square root of 2 is still the same thing. I didn't do anything there. Okay. So this 7 root 18 is the same as 7 over 3 root 2. They are just the same. I simplified it to get this. Now I've got this now. What's the next thing to do? You rationalize. So how do we rationalize? We need to remove this square root from 2. 2 has a square root. 3 doesn't have square root, so pay attention. There's no square root in this 3. It's with 2. Okay, so I need to remove the square root that is staying with 2. So what do? I'll use this root 2 to multiply up. I use the same root 2 to multiply down. Though, some people can actually use 3 root 2 to multiply up and down. It's correct, but it's ambiguous. It will give you a very big answer, which you still need to simplify again. So the best is just use that one that is inside that root. The root and the number inside it, use it to multiply up and down. So by doing that, we're going to have 7 over 3 root 2 times root 2. Root 2 multiply up, the same root 2 multiply down, leaving us with root 2 times 7, 7 root 2. Then we have 3. 3 is multiplying. There's an unseen one here, so 3 times 1 is 3. Okay? Whole numbers. Then root 2 times root 2 will give us root 4. Let me skip that one. Will give us root 4. Okay? This will give us 7 root 2 all over 3. Root 4 is 2. Root 4 is 2. So this is 3 times 2. This is more like 3 times root 4. So it's now 3 times, root 4 is now 2. So final answer we get 7 root 2 all over 6. So this can be the final answer. Though in JAM, this may not be the final answer. You may not see this in JAM, but this is the final answer. So we can say that this is the same as 7 over 6 root 2. Trying to say that 7 over 6 is the coefficient for root 2. So in most questions, in most OBJ questions, you may not see this in the option. You might see this one in the option. You may think there is a mistake. They're the same thing. 7 root 2 over 6 is the same thing as 7 over 6 root 2. Okay. The last thing I will do here is the number 4. Then the rest, you can go ahead and do the rest by yourself. So let me just do number 4. I want to drive the point that I said before, that if you have this, it's just this. This is what I said before. So I'm going to use number 4 to do this thing now. In number 4, I have 18 over root 2. Root 18 over root 2. There is root for both up, there is root for down. So what do? Put them into one root. Root of 18 over 2. Why am I doing this? Because I can see for myself that 18 is divisible by 2. 2 can divide 18. If it's not divisible, there's something else I will not, I probably will not go into this. I'll just go into multiplying with root 2 up and down. Do you understand? It will still give you the same thing. This will give me root of 18 divided by 2 is 9. And then root of 9 is 3. This one gave us a whole number. So that one I was telling, or you can say this is root 18 over root 2. Okay, it's something as root 18 over root 2 multiplies with the short part. You can multiply like this. Let's see what it will give us. So what it will give us? This will give us, this times this will give us root of 18 times 2. Okay? All over. So it's root of 2 times 2. This will give us root of 18 times 2 is 36. Okay? Then for the denominator, 2 times 2 is 4. What do we have? We ended up getting root of 36 is 6 over root of 4 is 2. And 6 divided by 2 is 3. So they'll still give us the same 3. So you can do it any of the ways that I've said above in solving the division of surds. So I'll give us something to go home and try. Please do the number 5 and the number 6. In the next class, we'll go over to conjugates and also multiplication, sorts involving brackets. And there are some sorts that comes out in WAEC that has to do with, still under conjugates. We'll handle that one in the next class. So just get yourself acquainted with this addition, subtraction, multiplication, and division. Do the ones I gave, the number 5, the number 6. Let me see whether I can still give us 2 more questions. So that I can give us just 3 questions to see whether we have really understood what we've learned. Now on this, let's look at okay, so I want us to look at all these ones. Okay, this one falls under division. This one is a combination of division and division, addition, and subtraction. So try doing all these ones. Okay, then you can send the answers to the number that you see on the screen. My number is there. You can send it to me on the WhatsApp, on the class WhatsApp platforms. Please do this as quick as possible and send it to us. The next video will continue from where we stop, and in that video we'll wrap up everything that has to do with Surds. I want to thank you very much for the time, your time, and your MB to go through all these lessons. Tune into this next time, and you shall be blessed. Thank you very much, and remain blessed.